Just going to take this opportunity to run through the more or less the last year of activities at FloWave. Now, I think most of you have probably seen FloWave at one time or another. I think we're the go-to location for drinks receptions now on the King's Buildings campus. So we've done quite a few demos over the years. But for those of you who haven't seen it or forgotten the great show we put on, I'll just give a bit of an overview of what we do and what we are. So FloWave is a subsidiary company of the university, built to operate the FloWave test facility. We are a test facility that operates at about 20th scale, providing tank testing for both wave and tidal applications. So the obvious thing is we're round with 168 wave makers located on a 25-meter diameter with a 2-meter working depth. That's designed to give us very good directional control and directional absorption characteristics, generating both long-crested seas, like you see here, up to very complex multi-directional spread seas. And really that is the large motivation for going for a circular tank, is being able to, now we've got no limitation on either the mean direction or the actual spread of direction. And that concept transfers over to the current side. So again, we've got 28 flow drive units located under the floor, and that allows us to generate current in any direction. Now, nominal maximum velocity of about 1.6 meters per second, although we have hit 2 meters per second in testing, which allows us to explore some very energetic tidal sites. But we have full independent directional control of the current, so we can program up a tidal ellipse, for example, and we're doing tests next week, actually, where we're looking at its control of a underwater vehicle, where they're looking at change in direction of current and so on. So very powerful capability. And what I'm actually going to be concentrating on in just a minute is the combination of these capabilities. So this is actually a test we did for a client. The slight yellow haze is their model under the water. I think this is waves into about a 0.6 meter per second current. I think they were a little bit shocked when they saw the loads from this. They told us to go as large as we dared with the waves, so we did, and then they asked us to turn it down. So this is really this is the unique capability of FloWave. There is one other circular wave tank, but the ability to do multi-directional current in combination with multi-directional wave is really what sets us apart. On the sort of support infrastructure side, we have elements such as our raisable floor for quick installation of models and access. We're constantly expanding our instrumentation suite. Things like load cell, which can be mounted flush into the floor, which is very useful for mounting large models on, both underwater and above water motion capture. We also have been successful in using ADVs in the tank now. They can be difficult with the clean water you get in a wave tank, but we've managed to get on top of the seeding issues with that. So we now have them available to use as well. And into the next year, we're looking to be expanding further. Project with Rockland Scientific Instruments in Canada, for example, which I'll mention later. We've also commissioned our on-site workshop now. So we have our dedicated technician, CNC mill and lathe. So at the moment, this is concentrating on turning out nice shiny brackets and load cell structures. But we're looking in the coming months to be doing full model builds for some clients. So that's going to be a really useful capability for us. So last year, you would have had, I think Stuart talked and gave you a bit of an overview of what we did. So a very, very quick recap. First year of operation, full year was 2014. Probably dominated by wave energy devices, but we also looked at foundation structures for tidal turbines. We had projects coming to us under Marinette, as well as EPSRC and private commercial clients. And also some slightly left field stuff, such as instrumentation from geophysics. It's actually the School of Geophysics in the University of Edinburgh, as well as some novel instrumentation ideas that were tested at full scale. So quite a varied first year. In terms of what we're doing now, I think it's actually good to concentrate on some of the research activities. So we have 3 ID Core research engineers with us. In terms, these are projects that are really hitting their stride now. This is some work from Donald Noble. He's very much been concentrating on the characterization of the tank, so we're really always exploring and getting a fuller understanding of some of the more novel aspects of the tank, and in particular the current generation side is a very novel system. So Donald's been doing work, for example, looking at the usable area of the tank and getting very detailed measurements that we can use to compare with, say, the CFD work that was done early on in the project. This is work he did looking at the usable area of the tank. This was done with a fairly simple instrument that gives you a 2-dimensional velocity, but now we're expanding this to use the Nortec Vitrino, which gives us 3-dimensional information and also turbulence information that we can use, so we can compare this with these existing velocity maps. And that's in plan view, but he's also been extending that to so we can understand the profiles as they develop across the tank. So this gives us an idea of velocity as it travels from left to right across the tank. And this sort of profile information is very useful when we're looking at site-specific applications for the tank and how it compares to site data, for example. On the wave side, we have Sam Draycott's work. Now, this is a project that's been going on for a couple of years now, and this has been looking at taking data from the Billiard Cruise site at EMEC. We've got a very capable tank in terms of its directional performance, and really to fully utilize that, we want to move beyond parametric spreading functions and look at more complex multimodal sea states, for example. So Sam's been taking the data from EMEC and basically going through a data reduction exercise that gives us a set of representative spectra that maintain that interesting directional information. And hoping when I think in say about a year's time we should be at the stage where that's a much more sort of packaged up product that we can start deploying in test programs. This has involved some quite complex directional measurement to really validate the kind of work, the kind of sea states he's getting. So on the left there you see a couple of directional wave spectra, and the right is what the tank's producing. So in order to do that, he's been developing a phase time path difference approach, which you can question him on later if that's of interest to you. Certainly don't question me on it. And that's involved in things like some quite novel directional wave gauge arrays and so on in the tank. So what we've really been concentrating now is on combining these two streams. So we're looking at so Donald's been looking at wave up until now, and Donald's been looking at current up until now, and Sam's been looking at wave. We're really concentrating on combining this into a combined wave current project. So part of Donald's work is to take theoretical wave current work, which allows it. So basically what we're looking to do is adjust the input into the tank so we get the wave height that we want. So Don's been looking at some theoretical work with that and applying empirical corrections to it, with the aim that we can take actually this is a measured EMEC spectra on the left, and correct that with, at the moment, quite low current velocities, but we essentially correct each component of that wave spectrum until we get and see that we get basically the same spectra at different velocities. So this is just a snapshot of that work, and this is sort of very hot off the press stuff. But hopefully, in the next sort of 3 months, we'll really be expanding that into a much fuller test program, and also extending the velocity range as well. So, in terms of external projects, most of the projects we have are been a little bit secretive in terms of video and photographs over the last year. So I picked out 2 which I think are quite interesting and which we can share. First one I think is quite a nice one for today because it's the XMed project, which was ran by Greg Payne under Tom Bruce's supervision, and it's interesting for us because it's the first large-scale tidal turbine which we had deployed in the tank and very heavily instrumented. So it gives us some very interesting, essentially, it's a very interesting demonstrator at one level. But it's also a very good test for us in terms of the capabilities of the tank. For example, the load cell that's mounted on was specced with this type of turbine in mind. So it was a very good, it was tested our abilities in quite a few senses. We also had our first offshore floating turbine. This is a hybrid platform from Inner Ocean. It's quite interesting because we were looking at the dynamics of the mooring system as well, so it was a test of our underwater and above water motion capture capabilities, and it also had a fairly rudimentary wind simulation system on it, which is another idea we want to expand over the coming years. So this was a fairly, and it was also quite an interesting test because it was a very large model. Those of you who were with us yesterday might have seen it towering above us. So it was, even though it's 20th scale, it's a very large thing at full scale. So it was quite a challenging thing, even just to maneuver through the door. So a quick look at what we have in the future. We're looking to be heavily involved in the Wave Energy Scotland novel wave energy converters projects. Not much I can say on that today other than watch this space, but we're in discussion with several of the clients there, and that should be something that's quite large for us in summer next year. Interesting collaboration with a joint UK and Canadian funded project, InStream, which our main partner there is Rockland Scientific Instruments. That will be looking at some very detailed turbulence characterization and measurement in the tank. And although I put it under 2016, but actually it's coming up in the next couple of weeks, as we'll be deploying our first large tidal array in the tank with a project in collaboration with Exeter, which is going to be about 15 turbines installed. And I'm sure that's keeping Duncan fairly busy at the moment. So in coming weeks, that will be going into the tank. And then we continue with collaborations with the School of Engineering here. Things like site-specific tidal investigations, novel instrumentation, also involved in Horizon 2020 projects. Polywec is an example that's coming up fairly soon, which is a polymeric power takeoff system, which again I don't quite understand, so but is certainly an interesting development. So with that, I'll hand back to Robin, and I'd like to point out that
This production is brought to you by the University of Edinburgh.